What's going on, guys? And welcome to my video about reactance of capacitors and inductors. Have you ever wondered why capacitors and inductors behave so differently in AC circuits? Unlike resistors, they don't simply oppose current with resistance. Instead, they create something called reactance. Today we'll explore the capacitor reactance, inductor reactance, and how they shape circuits. Let's start with capacitors. The formula for capacitive reactance can be seen on the screen right here. In this formula, Xc is the capacitive reactance, which is measured in ohms, F is the frequency measured in hertz, and C is the capacitance measured in farads. Let's say we have a 10 microfarad capacitor and a frequency of 50 hertz. This results in a capacitive reactance of 318 ohms. However, if we have a 10 microfarad capacitor and a frequency of 1000 hertz, we get a capacitive reactance of 16 ohms. This shows us that the higher the frequency and capacitance, the lower the capacitive reactance. This can be seen on the graph here, where the capacitive reactance is on the y-axis and it decreases as the frequency progresses through the x-axis. Now, let's look at inductors. Inductive reactance is written as XL, and the formula can be seen on the screen here. In this formula, XL is the inductive reactance, which is measured in ohms, F is the frequency measured in hertz, and L is the inductance and is measured in henries. The difference between inductor reactance and capacitive reactance is that inductor reactance increases as frequency increases. This can be seen in the following equations, where we use 0.1 Henry inductor at 50 Hz, which has a reactance of 31 ohms, and when the frequency is raised to 1000 Hz, the reactance shoots up to 628 ohms. This is also shown in the graph right here, where the frequency is rising along the x-axis, and this also results in the reactance rising at the y-axis. This means inductors pass low frequency or DC signals easily, but strongly oppose high frequencies. So here's the big picture. Capacitors and inductors behave oppositely. Capacitors have high reactance at low frequency and low reactance at high frequency. Inductors have low reactance at low frequency and high reactance at high frequency. This is why capacitors are often used in high-pass filters and inductors in low-pass filters. Together, they form the foundation of many electronic circuits, from radios to power supplies. And that's it. So, thanks for listening, and I hope you enjoyed the video.